Hello, and welcome to this video where we will now continue our journey in quantum mechanics from what we have seen in the last video, probability double slit, to now quantum double slit setup. So just to repeat what we have seen in the probability double slit experiment, we are presenting this again. Here you will see that the particles are defined by having their probabilities like 1 by 2, 1 by 2, 1 by 3, etc. And when they are fired by the gun at position 1, they pass through the double slit, which is marked by 2 and 3, and they end up on the screen, which is represented by the state 4 till 8. Now, what we see here that at the slit position 2 and 3, the probability of finding the particle fired from the gun is 50-50, 1 by 2, 1 by 2. And then once they cross the slit, they'll end up on the screen at different states marked by 4 and 8. And what we see interesting here is that at the vertices 6, which is part of the screen, the particles from the slit 2 and 3 interfere in their probabilistic terms to create the bigger probability of being found. That's why you will see on all other vertices it's either 0 or 1 by 6, but at vertices 6 it is 1 by 3, 2 times 1 by 6. Now, having said that, for the quantum double slit, we will not be dealing with probabilities, but with the coefficient of amplitudes. And that's why you will see here that the notation of complex number, which is used basically to define or to explain basically to explain the amplitude coefficient, also comes into the picture. Now, to make it simplistic, we have not drawn all the arrows from the slit 2 and 3 on all various combination. Therefore, this matrix is what is being represented as the amplitude of coefficients is non-unitary in nature. But if you draw it further with all the combination, it will tend to become unitary. Now, what we see here is that the amplitude coefficient when the gun was fired towards slit 2 and 3, the particle is 1 under root 2, 1 under root 2. And if you square it, which then represents the probability, it will turn out to be 1 by 2, 1 by 2. So not any difference from the probability double slit that what we have seen. The difference now comes from when the particle exit from slit position 2 and 3 with their complex amplitude coefficient, and there you will see that they will strike with a different amplitude coefficient setup on the vertices 4 till 8. So what we can do to visualize this better, let's start with initial state of x0 where the particle is at 1, and then we will evolve it towards a next state when it crosses the slit. So this is easy because here you will see that the x1 state represented by the slit position 2 and 3 is 1 under root of 2, 1 under root of 2, which again if you square it turns out to be probability 1.5. So not a great deal of difference. However, this is not interesting, so we should continue. And we evolved it further now, and that is where we're gonna see something very interesting, is in the sense, if you recall, in the probability double slit at vertices 6, the probability distribution was the maximum 1 by 3 compared to other either 0 or 1 by 6. Here, if you see that on the vertices 6, the the amplitude coefficients are not adding up. Now, this is something also to understand that normalization is also not complete here, because this matrix is, as we said, for the representation purposes is not complete, so it's not unitary. But then the point is that the particles which were behaving like particles at slit 2 and 3 all of a sudden are not adding up, as we have seen in the probability distribution case. Fact, it tends to go in a bit of a opposite direction, where you will see that the amplitude coefficient at at vertices 6 is now 0 because of what we call as a destructive interference, because now the amplitude coefficients are not adding up, or rather they are cancelling each other, and that is something very difficult to describe naturally why it is happening, but this is happening, and that is the gist of quantum computing, that when you measure it now like a classical system at vertices 6, it will collapse into a classical state of 0. But why it is happening is was the explanation is being provided here due to destructive interference, which is kind of very difficult to explain why it is happening naturally. So in a nutshell, what you see there is that the biggest difference between quantum double slit and the probabilistic double slit is that uh, the magnitude between the slit and the screen is retained. You can still have 1/6 amplitude coefficient squared equal to probability, but there is also a possibility of the phase change because of using the complex number. And what we see there, that in case of probabilistic system where the probabilities were adding up in the constructive format, in the quantum case they are naturally adding it to be destructive, and once measured at vertices 6, for example, they are turning out to be 0, which is the main message from this, that naturally why it is happening is very difficult to explain, but this is happening. Now with this, all the examples of a single particle-based system or a single system has been covered, and I hope you got the gist of why quantum computing is unintuitive and bit different, or rather way different than classical computing. I hope you have enjoyed the video, and I hope to see you in the next video, where we will be talking about what is called as a combination of systems or the assembled system. Thanks for watching, and I hope to see you in the next video.